The last video in the tkinter playlist showed how to draw a line between two mouse clicks on a tkinter canvas. In this video I'm going to develop a program that has the identical functionality, that is, draw a line between two mouse clicks on a tkinter canvas, but I'm going to do so in the object-oriented paradigm, which will involve creating a class and then creating an instance of that class. If you have not already done so, I recommend that you view the previous video in the playlist on tkinter before you view this video. Now, the application I'm going to build is going to be a very crude one. It's just going to allow us to draw lines on a tkinter canvas as shown here. If you look at the cursor, I'm going to click in that position and then I'm going to come over here and click somewhere else, and you can see it'll draw a line between those two clicks. So I can continue and draw various shapes using this simple application. So if I just continue here, I can draw a very crude stickman here, as you can see. The application that you've just seen was covered in the last video, and this is the program that achieved it. And you can see we have a function here, and if we come down here, we create a window, we create a canvas, we position the canvas. This will bind the left mouse click event to this function, which is this function here, and then we enter the main loop, and you can see here we have a variable assigned 0, and if you come up and look at the function, you can see here we have three variables: click underscore number, x1, y1, and down here we have x2 and y2, and we will be drawing as shown here using the create line method between the x1, y1 coordinate position and the x2, y2 coordinate position. Now, this program is described fully in the previous video, and I'm including it again here because what I would like to do is to compare this to the object-oriented paradigm solution for performing exactly the same functionality. Take a quick look at this function here, and you can see we have a selection construct, and what the selection construct is doing, it's either executing these program statements or these here. And if you look at these program statements, you can see we're getting the coordinate position when the mouse is clicked, and these are given to x1 and y1, and then we assign 1 to click underscore number, so that the next time we come to execute this, we will find ourselves executing these statements because of this conditional test here. And if you look here, you can see we're catching the second coordinate position, and this is the program statement that draws the line between the coordinate positions found. And then here we reset the number back to 0, so the next time this executes, we will execute these statements here. Now, you will note within this function we have global variables declared here, and in the previous video I pointed out that it was not a good idea to use global variables in this way. And when we move over to look at the object-oriented solution, we will not need to use global variables as they've been outlined here. So when we look at the draw line method as it will appear within the class, here remember we're dealing with a function when we talk about procedural paradigms, we will find that we don't have the variables declared in the same way. Now, this is the object-oriented program that will carry out the same functionality as the program we've just been looking at. And the first thing you should note is that this looks a little bit more complicated. To start with, you can see that all of this code I'm highlighting is a class, and the name of this class is here, drawLineApp. And if we look within the class, you can see here we have the draw underscore line method. Now, this is what we saw in the previous program when it was in its form of a function. But if you have a look at the code, you can see we have a selection construct which executes this, or it executes this. And this method here is pretty similar to the function we looked at in the previous program, and it performs exactly the same task, because if we come down here you can see that it creates a line using this method, and within here you can see we have various parameters. These two parameters are the start of the line and these two parameters are the end of the line. But what you will note is we seem to have this additional complexity of having the word self here. In fact, if you look at the class, you can see that the word self appears in many places. Now, if you are unsure as to what self actually means, I recommend that you locate a video I've produced on this channel that looks specifically at self in the object-oriented paradigm when you build a class. But briefly, I'll give an explanation here. You see, when you build up this class as shown by the code I'm highlighting here, what you will need to bear in mind that the class itself is not what executes. It's the instance of the class, i.e. the object. Now you can have many objects of this class, many instances of the class, and you need to think of the class as being a template or a factory, if you like, for producing these objects. Now each object that you produce is individual in nature. It just happens to have all of the attributes that this class is defining. Now each object that's created will hold information in self that identifies that object. So if you have 10 objects created from this, then self for each of those objects will hold a different bit of information that identifies every one of those objects. So object 1, for example, will have information held in self that identifies object 1. Object 2 will have information held in self that identifies object 2. Now, how does self get this information? Well, when you build a class like this one, you'll always require one of these methods. And if you have a look at the name of the method, it's __init __. And you can see here it has a parameter self. So when we come down here where we can see a program statement creating an instance of this class, what will happen? Python will arrange, you don't have to worry about this, Python will arrange to grab the identifier for that object and it gives it to this parameter self here. Now every time an instance of this class is created, this will execute and this will receive an ID for that instance created. So if you create 7 objects of this, we'll say, then self for each of those 7 objects will have a copy of an ID which identifies each of the objects specifically. Now the mechanism for achieving this involves you having an understanding of namespaces and so on. So I'm not going to worry about that in this video, but what I will say, your responsibility as a programmer is when you create an instance of a class, as this line is doing here, then you have to ensure that inside your init, in the parameter list here, you have self. Because when this is created, Python will automatically produce an ID that will be stored in here. So make sure when you produce your init, you always have self here. Now let's consider this function which I showed you at the beginning of this video, and it's the procedural solution that we also looked at in the previous video. And I would like to highlight where the variables were declared inside this function, and you can see they're here, click underscore number, x1, y1, and the global variables. And here you can see I've used 2 local variables, x2 and y2. Now let's compare this function with its method equivalent as that method appears in the class that I've produced for this video. And if we have a look at a part of the program, you can see I've shown all of the class. Now here you can see we've got the global variables, and here you can see we have the local variables. But if I come down here, you can see that click underscore number, x1, y1, x2, y2 have been placed inside the init method, because when I create an instance of this, this is the first thing to execute, and these variables here will be created as part of the init execution. Also note in front of the variables we've got the word self. Now this ensures that each instance created has its own copy of these variables. It also means that because I've put self in front of these variables, they will be available to all of the code throughout the instance of this class. So every object and every method defined in that object will be able to gain access to these variables. And if we come down to this method here, you can see that's precisely what I'm doing. Here, for example, self.x1 is assigned what the event tells us the coordinate position for the x's when the mouse was clicked. Here, self.y1 is assigned the y coordinate of the event. Here, you can see that self.click_number is assigned 1. And if you look to these three variables here, you can see that they appeared here. If we look to the else part of the selection construct, you can see here we've got self.x2 is assigned the x coordinate of the event that takes place when I click on the left mouse button again. And here you can see the y coordinate is given to self.y2. And down here you can see that we have self.click_number being assigned 0. Now if you consider all of the variables that I'm highlighting here, you can see that they were declared here inside the init. Whereas if you go back up to this program, you can see the positions they were declared in. So when we deal with the object world and we're dealing with classes, it's usual to put the variables that you want to be available throughout your application here. And this means that each of these variables is accessible in all of the methods that are defined within this class. As you can see here, those are the variables that are used, which were effectively declared here. Also of importance is the header of the draw_line function and method. Let's have a look at the function first, and you can see that we have event here. Now that means that this function is capable of receiving information from Python about the event that's taken place, and the event we're interested in is the clicking on the left mouse button. If you come down here and have a look at the header for this method, you can see here we have the same thing happening. We have event here, but we also have this self. Now that is there because this method needs to know which object it is working with, and the ID of the object it's working with will be held in here. So this method then would belong, for example, to object 1, on the basis that when the instance called object 1 was created, the ID would automatically be generated by Python and would be passed to this parameter here within the init method, which is the method that would execute every time you created a new instance of this class. And of course, if you then create a new and different instance of this class, this self would obtain the ID of that newly created instance, and this method then would have here the ID of this newly created instance. So you could have two instances in existence, two objects in existence, and they would have a different value for the ID, and the self would be different. So this self would be for object 1, this one would be for object 1, all of these here would be for object 1, but in the other object this would hold the ID of object 2, this would hold the ID of object 2, and all these would be the ID of object 2, and so on. Let's now turn our attention back to the procedural code solution to the program we're developing in this video. And here you can see I'm showing part of that program. What's missing is the top bit of the program and the function that is used for drawing the line. But if we consider this bit, we can see here that we're creating a window. On this line we're creating the canvas associated with that window, and these parameters are setting the width, the height and the background color of that canvas. This line uses the grid method to position the canvas on the window. Here we're binding this event to the function, the draw_line function, that I haven't shown in this bit of the listing. Here we set the click number to 0 and then we enter the main loop. Now in the object orientated solution, these lines here are set up inside the init method, as you can see by this snippet of code. On this line, you can see we're creating the instance of the canvas class, and these are the parameters we're sending in. On this line, we're positioning the canvas, and here we're binding the button click to the method draw line, and here you can see we're setting the click number to 0. Of course, if we look at this program statement, we can see that the parameters look different to how they did when they were up here. Likewise, if we look at this line, we can see the parameters here look a little bit different than we set up here. But if we consider this line, you can see that we're still using the left mouse click event as we are here. And here you can see we used the draw underscore line when we were in the procedural one. The difference is here we still use the draw underscore line, but of course we have to have the self and the full stop in front of it because we're now in the object orientated world. And if you have a look, we can see that when we have this click underscore number equals 0, here you can see we have to put the self full stop in front of it. What we have got missing from this init method, we've got this line missing. My window is assigned tkinter. In other words, when we have this init, we don't use the init to create the instance of the window that we're going to be placing this canvas on. We are, however, using this parameter here to receive the window onto which the canvas is placed. Let's now consider these two snippets of code. Here you can see we're looking at the class, and I'm concentrating on the init method. If we come down here, this is the code that creates the instance of a window, and this line is going to create an instance of this app, which of course is an object, and it is an object of this class. And here we go into the main loop. When the program executes, this is going to be the first line to execute, and we can see we're creating an instance of a window, and it's going to be bound to this name here. When we come onto this line, we're going to be creating an instance of this class, and because it's this class we're creating an instance of, the thing to execute next will be this init method. Now what we need to do is, looking at the init method, we can see here the parameters. Now these parameters are going to receive their input from these arguments here that I've lined up when I've created the instance of the class. The first thing we need to say is when this line executes, an ID is going to be created for the instance we're creating, and that ID will be passed to self. So when you look at these parameters here, you'll see, if you count them, we have 1, 2, 3, 4, 5, 6 parameters. If you come up here and count them, you can see we've got 1, 2, 3, 4, 5, 6, 7 parameters. Now that's because we have to realize that when you create an instance of a class using a line like this, the self is automatically generated by Python and stored in here. When I say the self, I mean the ID is automatically generated by this line and is put into this parameter here in the init. So when this line executes, an ID is created, and that ID is passed here to this parameter. This argument, which is the name bound to the instance of the window created on this line, is passed here. Here we can see we have an argument which is saying let width be assigned 400. Now that 400 is going to be passed to this. If we come on and look at this argument, we can see the height has been assigned 300, and that 300 is going to be given here. This color is assigned white, and this argument white is going to be passed to this. Here we can see row is assigned 0, and this 0 is going to be given to this. Here we've got column is assigned 0, and that 0 is going to be passed to this. So just to summarize with respect to the parameters, these arguments here, we can see there are 6 of them, and here we can see there are 7 parameters. Now that's because we always have to remember we need this self. So if we come to these arguments here, we can see that they are going to be passed to these parameters here. Self automatically gets the ID of the object being created. Now these parameters, we can see on this line, are the arguments to the canvas class. So if I take this my window here, it's passed to here, which in turn is passed to here. If I take this width of 400, it is passed to here, which in turn appears here to be assigned to width, which is an attribute of the canvas class. This height of 300 is passed to here. That then is this, which is assigned to height, where height is a named argument defined in the canvas class. Here we can see we've got white being passed to here, and here we can see we're using that white and we're assigning it to BG, where BG is one of the named arguments inside the canvas class. Let's now consider these two arguments, and in this case we can see row is assigned 0. Now that 0 will be passed to here, and here we can see column is assigned 0, and that 0 will be passed to here. Now the row and the column that you can see here as the parameters to the init are used on this line in this position and this position here. And here the value of 0 is given to row, and here the value of column is given to column. And this grid method now knows that it is to position the canvas at row 0, column 0. As an aside, take a look at this, where I'm assigning width to width. Now, taken in isolation, that might seem a little odd. And to a human being looking at this, you may say, why am I assigning width to width? However, you have to realize that Python understands what's going on here. And what is going on is the following. Here, you're assigning 400 to width, and that 400 is passed to here. When it's this width, which we're using here, it is a parameter of the init method. This is an attribute of the canvas class. Although to us assigning width to width looks a bit odd, this is a parameter of the init, and this is an attribute of the canvas class. To emphasize the point, let's look at this where height is assigned height. Now we have to realize that this height is a parameter of the init method, and this height is an attribute of the canvas class. Of course, it could be argued that here I could have used different words for width and height, and a potential confusion such as this might be avoided when somebody else reads my code. However, I'm going to come back to this in a later video. Let's now turn our attention to the full object-oriented program and concentrate on this line. And what we can see, we're using the bind method, and we're binding this event, which is the left mouse button click event, and when the event takes place we wish to execute this here, and this is the name of this method, as you can see here. And what you need to realize, we have to have this word self dot in front of it, and this tells us that the method is defined in this class, as you can see here. Now when this program executes, we're going to create a window with this line. This is going to place the application we've developed in that window, and then we're going to enter the main loop. So when we look at the runtime, you're going to see this. This is the application and this is the window. And what's happening now, we're here in the main loop and we've set Python up to respond to clicks of the mouse. And I'm not going to do what happens when we click on the mouse in this video. I'm going to do that in the next video. Check out the supporting website for these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.